Hey physics kids, Mr. Johansson here. Just want to finish talking momentum of a closed system. So what would a momentum of a closed system be like? Well, this has a lot to do with Newton's third law, action-reaction. Think about this. I'm going to shoot a gun, right? So, bam, I pull the trigger and notice the gun recoils. Why does the gun recoil? Well, the momentum is closed. Before I shoot the gun, the momentum of the gun and the bullet, the system of the gun and the bullet is zero. All right, after I shoot the gun, I can't make up momentum. In other words, the momentum must still sum to zero. How can that be? Well, P before equals P after. All right, so the momentum before, which is zero, must equal the momentum after. So the P after must equal 0 kilogram meters per second. How do we get that? How do you get 0 kilogram meters per second? Like, it's bothering me. How do you get 0 kilogram meters per second? Well, let's consider, shall we? All right. Here's the bullet shooting out that way. What's the mass and velocity of the bullet? Well, it's a tiny mass and a huge velocity. What's going on with the gun when that explosion occurs? All right, well, the gun has, compared to the bullet, a really large mass. And because of that, it has a very small velocity. Imagine shooting a gun where the gun is shooting a bullet and the bullet has more mass. How's that going to work out for you? Let's say your gun is shooting a 30 kilogram bullet and your gun only weighs 1 kilogram. Do you want to pull that trigger? Well, the thing is, the gun would go back 30 times faster than the bullet would. So I'd say that's a bad idea. They have to equal each other. So you put in whatever you have and set the two things equal to each other. Let's do one, shall we? Let's make up a quick problem. A 5 kilogram gun shoots a 0.01 kilogram bullet at 500 meters per second. What is the recoil of the gun? Now, this is such a simple thing. Given's formula S&S, we're riding the line here. It could work for it, but it's not necessarily the best way to do it. Graphically, makes a lot of sense. So let's look at it this way. Mass of the gun plus velocity of the gun equals what? Well, mass of the bullet times the velocity of the bullet. Okay, let's be good here. Let's solve algebraically. So what are we looking for? We're looking for the velocity of the gun. So if we divide both sides by the mass of the gun, we end up canceling here. So the velocity of the gun equals the mass of the bullet times the velocity of the bullet divided by the mass of the gun. How do we know if the algebra is correct here? You know physics? What do we do to see if the algebra is correct here? Mass of the bullet and the gun cancel out. We're left with the velocities. So we're left with meters per second. That's what we're seeking. So we have a good chance of this being correct. So sub in. Mass of the bullet is 0.01 kilogram times the velocity of the bullet, which is 500 meters per second, divided by the mass of the gun, given as 5 kilograms. Well, this is all right. So 0.01 times 500 divided by 5 equals, did you see that one coming? The gun is going to be moving backward at 1 meter per second. And that's about what a gun does. Now, you're holding the gun so it stops, but if you could think about it suspended on a very long cable, when you shoot that gun, wouldn't it be reasonable to see that gun push backward at a speed of approximately 1 meter per second? Seems pretty reasonable to me. So that's momentum when you have it as a system. You'll see those questions pretty often, and it's action-reaction force. When you push that, you get pushed back. And realize why we have to think momentum of a system. I've heard people say that whatever the velocity is going that way, then the velocity has to be that way. How would that work? With a big, massive gun, you shoot a little bullet, and suddenly this gun is moving back at 500 meters per second? You're inventing energy. You can't do that. It's momentum that is conserved. And momentum is conserved across a wide spectrum of all things, from the very tiniest things to the very largest things. Momentum is conserved. So how you do it, set momentum before to momentum after, and if that's going to be zero, then just figure out one way plus another way. Their vector quantities have to sum to zero. So mass times velocity of the object being shot out must equal mass times velocity of the object doing the shooting. Okay, in the Enigma number 19, in the try it yourself problem, the two skaters who push back and they measure their velocities. One knows his mass, wants to know the mass of the other one, and they figure the velocities, and the known mass lets you know the unknown mass. That's how momentum works. Hope this helps. Mr. Johansson saying, have a nice day.